boy Tricider Weekend Academy-ish. Guys, let's dive right into this. With a tie for the top two, can Amelia have her own button? And something about springs. I find it fascinating that the top two voted things, one of them has literally nothing to do about the assessment on Tuesday. Amazing. Amelia, can she have her own button? Absolutely not. There are 4 buttons, and how fair is that to give one student out of over 100 their own button? I don't think that's fair. Plus, wouldn't that be playing favorites? And we all know I don't have any favorites. I love everybody equally. Let's dive into the other question, though. When should we use F equals kx? It should be fs versus us 1/2 kx squared. So let's chat a little bit about that. These two equations that we have, right? That first one being fs equals kx. This is officially known, as we had said, as Hooke's law. Okay, and this talks about the spring force and how it relates to how much the spring is stretched or squished, right? K being spring constant. Whoa, that was a super cool line that was just made for no reason. X, right, would be in meters, talking about stretch or squish. Spring constant would be in newtons per meter, and of course, force, as always, is in newtons. Now, when would you use this? If you knew a force about a spring and wanted to know spring constant or how much it was stretched, or if you knew spring constant and stretch and wanted force, or if you wanted the stretch but knew the force and the spring constant. You would use this when you were talking about forces. Be the primary reason for that. Because remember, we can't use this with work because it's a non-constant force. And a reminder, the big thing from this was we had that graph, which was fs and x, and it was linear like this, and the slope of this graph was in fact spring constant. Higher the spring constant, the stiffer the spring. The other one, us equals 1/2 kx squared. Just a quick unit review. This is in joules, newtons per meter, and then this is meters, right? In there, but then it would get squared, which is how we get to end up being a joule. This is about the potential energy stored in a spring, right? So how much potential energy is being stored in a spring if it's squished or stretched. So when would we use this? We would use this when we're looking for how much energy is stored in the spring, or how much energy we're gonna store in a spring. Because what if I had, a spring that was just sort of chilling, right? And then I had a box that was at some height h that I was dropping onto it. We could figure out, well, like this would all be ugh, and then if this gets squished, this would be us, right? So we can figure out how much energy I would store in the spring given a certain amount of stretch or squish. Here would be a compression or a squish, right? That's really the big thing here is remember that us, anytime we see that U, that's potential energy, right? Stored energy. And we said potential energy in general was stored energy due to position or condition. This is a condition. Being stretched or squished is a condition of that's going on here. Back to the Tricider. We'll keep rolling until we hit a mark that's ridiculously too long. How would you solve a problem where a spring gets incorporated into a ramp scenario? So how I would solve it is by using physics. All right, I get what you mean. I think it depends. So what if, let's make up a scenario. Let's say I have a ramp like this, and I have a spring here that's squished, and I have a block here, mass M, and I want to know how high up would this block get. Now, if I was going to try to solve this, what I'd most likely do is think about the scenario. Well, this spring had to be squished some given amount, so this spring would have to be storing spring potential. Then when it moved along the ground here, it would be that spring potential would go to kinetic, and then when it stops at rest up here, it would be UG. So this would be one way to incorporate it. If we talk about the words here, in the beginning, all of the energy is in the spring. None of the energy is in the block. Nothing. Then here, the spring would do work on the block, increasing the energy of the block, adding energy to the block, and then as it's kinetic energy, all of the energy is in the block, all of it, all of the energy is in the block. Then as it goes up the ramp, it's going to get up here to be UG. When it's up here, now the energy would be in the Earth block system, right? Reminder that if Earth is not in our system, we're not allowed to talk about UG. So this is one way we could incorporate springs pretty easily, or again, any Hookean object. So it doesn't have to just be a spring. It could be a bow or something else that I tell you that's Hookean. Doesn't really matter. For the most part, it's sort of bungee cord type things, rubber bandy type things, and springs. But honestly, a lot of times springs, because that makes the math flawless if we use the springs. But yeah, this is one way, because we could easily figure out how fast this is going or how high this is going to go. Or you want to make this really complicated, I could also figure out, right, because right here it'd be a combination of both of these things, right? I could figure out, well, when it's 1 meter above the ground, how fast is it going? It'd be an easy way to incorporate springs into this. I mean, we would also do the same thing backwards, right? If we just would have dropped it backwards as well. But this would be the easy way to incorporate this. Let's head back to the Tricider. How could we justify the difference between C and D on 502? Both have... How much work do they have? How much work do they have? Because I'm really hoping that's an O. Because as far as I'm concerned, numbers get units, don't they? Don't they? I'm going to ignore this anonymous person, whoever wrote this. And those of you that voted for it, no one in here wrote in here a con of this? No units. I'm looking at you, whoever you are that wrote this. So if you remember those two scenarios from 502, I'm not going to pull it up. But, so for 502, we had the two scenarios, and in one of them, it didn't change at all. Nothing changed. It was just doing its thing and then still doing its thing. Nothing changed, no changes. Now, in I believe that's D. And in that scenario, nothing's going on. So don't touch it, and it's going to keep going at the speed that it's going. That's a scenario of no work being done, nothing. And the other scenario, which is C, it's going in one direction, and it's going in the opposite direction at the same speed. In order to make that occur, what we'd have to do is remove energy from the system, right? To first slow it down to stop. And then I have to add energy back to speed it up in the other direction. So in one scenario, I'm not doing anything. In the other scenario, I'm removing energy and then adding the same amount of energy back. So overall, if we think about the overall process that's there, there's no change in energy in either of the systems. Therefore, there's no network for either of them. But if you want to get specific, for D, don't touch it. No work. No, don't touch it. C, you got to touch it. You have to interact with it. But in the end, you're left with no net work, would be the big way to justify that there. When the system is everything, is there always going to be no network? No. No, yes, no, maybe. So it depends. It's complicated. When we say everything, there still can be something external. Because normally when we say everything, what we normally mean is the object in question, any ramp or ground it's on, and the earth. That's really our everything. So, and sort of an example to talk about this would be like the second half of, so let's just go 505 in general. The first part of 505, even though I think my system should be everything for that, there's something external that comes in and stretches the bow. And I don't know what it is. And because I don't know what it is, I can't really include it in my system. Because it's like, well, it's everything. Well, what's that thing that's doing that? Something. So there's something external that comes in and stretches the bow. But then after the bow's stretched, my system's now everything, which is just the bow and the arrow. So I think that in a system like that, whenever there's some mysterious unknown thing that's coming in and stretching the bow, that's when it really becomes the no network kind of deal. Look at the problem, and I think when there's something from the outside coming in to do something, that's when we're going to get delta EFD. But when it's just a thing and earth and ramps, then that's when we can deal with none of that. Can you explain network and how to figure it out if there is any network and a problem? Kate, I think I answered this, but just to tack on a little bit, Kate, would be change in energy. So if there's an energy change in the system, then that's where we're going to have some network. No energy change in the system, there's not going to be any network. There's no exact equation But that's how we would do that. Is GPE only used when the system includes the universe? So it's not the universe. Yeah, whoever. Yeah. Yeah. It's just when the Earth. So it's not necessarily the universe. It's specifically the Earth is the important part. So you need Earth in your system. This one. So for those of you that can't, I don't know how big this is on the screen. How come FX? Basically, what it's asking is how come Trig is Trig? So what we always said is we don't memorize crap. We look at the triangles. So if I just jump onto this quickly, if I had a triangle that was like this, right? And I have this angle, and I'm trying to find this side here. If I paint this red, I'm trying to find this side. What trig function would I use? Well, I would use cosine because it's adjacent. But if I had this angle up here, like theta 2, I would use sine. So the reason things are different is because things are different. So this is why we always check our trig functions. It's like what I told you with FG. We make the triangles for FG and then look to see what's going on with Vox and Voy and all those. We make the triangles. So what you should do is make the triangles and look to see what angle you have, because that'll determine the trig function. There are no rules as this is always this. That's not how any of this works. Check your trig, check your triangles. Do you need Q? Oh, Q! Sleepy. Do you need Q and ramp height given to you to solve curved ramps? No. So you could have a frictionless ramp, curved ramp, so you would not need Q. But heights, yeah, you normally need to know how high stuff is, or some other way to determine how high it is. Like in that last example problem, we have 506. There was like that little, like, we can determine the height of it by using the length. So just watch out for little things like that. The process of finding the algebraic expression of heat. So heat in general, heat for us, for the most part, is going to be the work done by friction, which will be F times displacement. But remember, work is also change in energy, but if it's friction specifically, to be change in heat. So this would really be the process of trying to determine the how much heat is in a ramp style problem, would be something like this. Or if it was just on the ground, would be like just on some sort of surface. Surface friction would be the way to do this. Now you'd need to determine the force of friction somehow, and if it's forces, we just go back to that, right? Friction's really enjoyable. So yeah, but that's the basic process of that, because remember, deltas are always final minus initial, and things should not have initial heat. They should not initially be on fire. So it's really that the force of friction times displacement would be the final heat there. So that would be the main way to solve most of those. Can you explain the situations in which we should state the base level? I think the only... Thank you. You're welcome, Kate. I think the only time to ever move the base level is if it doesn't hit the ground in some fashion. So I think that was sort of the trick with 504, was it never got back to the ground, really. So I think that's an indication we're going to move it up. But if it's getting towards the ground, that would be. Another example would be, what if it was just like on a ramp on a table? That's another situation where I would probably move the base level to the table instead of just using the ground, because then you're always going to have like table height floating around in everything you would do. An example of that would be ball in a cup. So if we were going to do ball in a cup, I would split ball in a cup into two pieces, the on the table part and the off the table part. Off the table part, we should... No problems with that at this point. That should be slam dunk. It's 2D kinematics, make a double-sided chart. But on the table, I would actually set the base level as the table, so that way I could easily do energy. You can still easily do energy if it's not the ground. But yeah. But yeah, that, I mean, ball in a cup might be an interesting thing to go back and revisit for you guys with that kind of stuff. I will assume the system is everything unless otherwise stated. Just where Q is included in the equation. I mean, anytime there's air resistance or friction, there will be some sort of heat generated. Curved ramps, it's the exact same UG to K at the bottom of the ramp. The deal is you can't use forces. You'd have to use energy, and you can't find heat, so you have to be frictionless. Or I'd have to tell you what the heat is. 505, you cannot do... 505B. Why can't you do 505? The trick with 505 is in the beginning, you can't. There's energy being added into the system in the beginning, so there's a change in energy. So we don't know what the initial energy is. But later on the problem, when it's us to K, you can do conservation of energy. Colleen, you're so welcome. Pendulums are just UG to K back to UG. That's the main thing with pendulums or any sort of thing that swings like that. A pendulum is ridiculously similar to Skater Girl, where she's just a skater girl, right? So it's very, very similar to that. But it's just UG to K to UG over and over and over again. Cool. Final thoughts. Remember, we got two methods for solving problems. Either we're doing delta E FD work or we're doing EIEIF. The big indicator that splits those two parts in half is, do I have something external, something mysterious, something adding energy or removing energy from the system? FD delta E work. If I, however, know everything that's going on, I'm comfortable with all the things in the problem, there's no weird thing from the outside, that's an EIEIF. In all these problems, we're also going to ask three primary additional questions. Is it moving? If so, kinetic energy. Is the object above the ground or the base level? If so, UG, gravitational potential energy. Is there a Hookean object that is stretched or squished? If so, US, or spring potential energy. Those are really the big breakdowns of a lot of this. It's really break down to the two categories and then, all right, what's going on here? If there is work being done, it's changing the energy. And what energy is it changing? Is it changing the spring potential like it was in the beginning of 505? Or is it changing the kinetic energy like it was in 502? It really will determine on the scenario. Big thing for us would be make a diagram if you don't have one, right, to figure everything out. Set your system if you want it to be something other than all of the things listed. And other than that, happy studying. And until next time, adios, everybody. Goodbye. 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 Adios. Sayonara. Imagine if, like, right now I just put, like, a super secret and was like, there was a bonus question. And the answer is purple teen. Imagine, like you got this far. You know what the problem with doing that though is, like, someone would tell someone else. Like, it couldn't just be like you got to the end of the video. So like, congratulations, number 5 is 86 joules. You know, like you can't do that because then like you guys are just like, do I go right in the group chat? You know, or someone in the group chat would be like, hey, better watch you in the video. Yeah. But imagine if I could do that. Man. Okay, bye.